In this example here, we want the second derivative, so we're going to have to differentiate it once and then differentiate it again. So we have chain rule and product rule. So I'm going to first differentiate the e function, so it just stays the same, but I have to multiply it by 2 with chain rule. So that represents the first part of the derivative, and then times cos x. Plus, so here's the product rule part. It's going to be e to the 2x minus 1, and the derivative of sine x is going to be derivative of cos x is negative sine x. Okay, so then simplifying this a little bit, I'm going to factor out the e to the 2x minus 1, and I'm left with 2 cos x minus sine x. So that represents my first derivative. Now, the reason why I factor that is I think it's easier now to differentiate one more time. So my second derivative, then I'm going to differentiate the e function, times that by 2. So there's the derivative of the e function. And then I'm left with the 2 cos x minus sine x. I don't differentiate that part yet. So now as I apply the product rule, I don't differentiate the first function, then I differentiate what's in the bracket. So I get negative 2 sine x, so derivative of cos is negative sine, and the derivative of sine is cos, so I end up with an expression that looks like this. Okay, there's again is a common factor here, and so I should try to simplify this. So as I factor out the e 2x minus 1, I'm going to be left with 4 cosine x minus 2 sine x. And over here, I'm left with 2 minus 2 sine x minus 1 cosine x. Okay, so I do have like terms, which allows me to simplify this even further. So, just so that you know, this 2 ended up here and here. Okay, so that's if you're wondering where that 2 went. So I only factored the e to the 2x minus 1, and then I multiplied that 2 into those brackets. So then I end up with 2 e to the 2x minus 1. Combining the like terms, I get 3 cosine of x minus 4 sine of x. Okay, and that's about as far as I can simplify that.